Hey everyone, and welcome. So today we're going to talk about a really powerful Apex tool for handling errors gracefully, one that you might not be using as much as you should be, the transaction save point. We're going to see how you can stop one tiny error from derailing your entire operation. Just imagine this for a second. You've built out this pretty complex piece of automation, right? It updates a main record, creates a few child records, maybe it shoots off an email, a lot is going on. But then some minor validation rule fires on a non-essential record, and the entire thing just fails and rolls back. Does that sound familiar? I bet it does. It's super frustrating, and it happens all the time.
So why does that happen? Well, it's because, by default, Apex transactions are completely all or nothing. A single unhandled DML error means the whole chain of events in that transaction is just gone, undone, like it never even happened. Now, that's great for keeping your data clean and consistent, but man, it can be incredibly rigid when you're dealing with complex business logic.
But what if you could have a safety net? What if you could protect the most important parts of your transaction from failures in the less important parts? Well, guess what? You can, and it's called a save point. Honestly, the best way to think about it is like a checkpoint in a video game. You get to a safe spot, you save your progress, and then you can keep going, knowing that if things go sideways, you can always just warp right back to that save point.
So let's really dig into what that means. A save point is literally a marker that you place in your code. It's like telling the Salesforce database, hey, freeze, remember everything just the way it is right now? This gives you the power to come back later and say, whoops, something went wrong. Let's just go back to that marker, without having to scrap the whole thing.
I mean, look at the difference here. It's night and day. The default behavior is just unforgiving. One little mistake, and everything you did is gone. Poof. But with a save point, you get so much more flexibility. You can actually isolate the parts that might fail, handle the error, and most importantly, keep all the critical work you did before you set that save point.
Okay, so how does this actually work in your code? It's actually a surprisingly simple pattern. Let's walk through the play-by-play for setting up a partial rollback. Now, the order here is everything. First, you do the stuff that absolutely must succeed. No questions asked. Then, right after that, you set your save point. That's your safety net. From there, you try to do the risky or optional work inside a try block. If something goes wrong and an exception gets thrown, your catch block kicks in, calls the rollback, and takes you right back to that save point. And the best part? The transaction just keeps on going, letting all that critical work you did at the beginning get committed successfully.
All right, theory is great, but let's look at some real code to make this more concrete. We've got a classic scenario. We need to update an opportunity stage to closed one. That's the critical part. Then, as a secondary thing, we want to insert a custom log record. Now, that logging is nice to have, but we would never want a logging failure to stop the whole opportunity from being closed. So, first things first, the critical step. We grab our opportunity, we update its stage. This is our non-negotiable. This is the whole reason our transaction is even running. And we do it first before anything else has a chance to mess things up. Now, check out the timing here. It's super important. Right after we know that critical update worked, boom, we create this save point. We're essentially saying to the system, okay, the opportunity update is solid. Lock in this state. This is our fallback point. And now, inside our try block, we attempt the optional operation, inserting that custom log record. This is the part that could, blow up. Maybe there's a validation rule, a missing required field, who knows. This is the operation we want to isolate and protect our main transaction from. And here's the rescue mission. If that insert log statement fails, the catch block fires. We call database.rollback, and we pass in our save point variable. Instantly, the database zaps away all the changes that happened after that save point was created. So that failed log insert is gone. But, and this is the crucial part, our opportunity update, totally safe, untouched. It's still there, ready to be committed. Okay, this feature is awesome, but it's not a silver bullet. You gotta know the rules of the road. So let's get into the fine print because this stuff really matters. So let's just nail down these core ideas one more time. A save point marks a specific state in the database. The rollback only affects things that happened after that marker. Everything before it is safe. This makes it perfect for those truly non-critical side jobs, like logging or maybe creating an optional related record. You always have to ask yourself, if this side thing fails, is it ever a deal breaker? If the answer is no, a save point is probably a great fit. Okay, everyone, listen up because this next point is critical. This is the #1 gotcha that trips people up with save points. Governor limits are not refunded. So if your failed insert statement used up one of your DML operations, you don't get it back. The rollback undoes the data changes, but it does not give you your limits back. You have to be really mindful of that when you're designing your code.
So the Apex Savepoint, it gives us a fantastic way to build more resilient, more fault-tolerant transactions. And that leaves us with a final question to take back to our own code bases. Where do you have a complex process that's vulnerable to a single point of failure? Where could this safety net pattern turn a catastrophic failure into just a minor recoverable hiccup? It's definitely something to think about. Thanks for tuning in.